Hello dear viewer, welcome to the first of the two-part video on special products. Before proceeding to the contents of the video, I do highly recommend that you watch the other videos contained in this channel as the topics are chronologically ordered for your convenience. This is Jason Bogayan to help you through your mathematics ventures. In light of this topic, let's challenge ourselves to achieve the following objectives. The first is to identify the different special products. The second is to solve for the given special products involving squares. And the third is to solve for the given special products involving cubes, which is in the second part of this series. But first, let's have a small recap, a pre-activity. There are many concepts that are enclosed within this topic, so reviewing some prior concepts is essential. The first is simple. Try to expand the following exponential expressions, and if possible, you may simplify them. I'll give you 5 seconds for each item since this is just a simple recall. The first is to expand the square. This one is already quite obvious. The square of a, or a squared, will be equal to a times a. How about the next one? N raised to the 5th power. N raised to the 5th power can be expanded with 5 n's, or basically n times n times n times n times n. Now, 10 squared. This one isn't a letter, so simplifying them should be possible. 10 squared is equal to 10 times 10, and 10 times 10 equals 100. Now might be a good time to say that you must have a background knowledge of squares and cubes of numbers. If not, reorient yourselves first before proceeding. How about the square of 3a, a coefficient with a variable? Recall the law of exponent. A product raised to an exponent is equal to the first factor raised to the exponent times the second factor raised to the same exponent. So that would be 3 squared times a squared. 3 squared is equal to 9, while a squared will stay as a squared with their product being 9a squared. The last one. Do you know this? The square of the sum of a and b. If you are advanced, then good for you. This is quite complicated, but all we have to do is expand and multiply afterwards. Therefore, quantity a plus b from the sum of a and b squared will be equal to quantity a plus b times quantity a plus b. And simplifying this further, this should be a squared plus 2ab plus b squared. This is a prime example of what we will be dealing with later on. Now that that's out of the way, let's recall prior knowledge even further. Another concept to grasp is the existence of polynomials. You must know when a polynomial can be simplified. This might be confusing for those who are unaware of similar and dissimilar terms. Thus, if you want to be oriented upon this, watch some videos regarding operations on similar and dissimilar terms. Right now, let's have this very simple example for now. X plus y plus xy. What do you think is the simplified form? Recall that you are only to simplify similar terms. Do you see any similar terms? This one is an x, this one is a y, which are separately entirely. But what about xy? This is also different from x and y, therefore there are no similar terms and everything will stay as is. Now how about this? X squared plus xy plus xy plus y squared. As we can see, we have similar terms xy and xy. If we add them, we should have 2xy since they have an invisible coefficient of 1. Meanwhile, x squared and y squared will remain untouched. Another example, 3xy plus 3x plus 2y plus 6y. Our only similar terms here are 3xy and 6xy since they both have the variables xy. Thus, if we simplify this, 3 plus 6 will be 9 and with the xy, this will be 9xy. Copy the others because they were untouched. For the fourth, 2x squared y plus 2xy squared plus 3xy. As we can see, x squared y and xy squared looks kind of familiar, but are actually not. The squared variables are different, x for the first term and y for the second term. This makes them dissimilar. Meanwhile, for the third, it is already evident that it is different. Therefore, there are no terms to simplify further and you can just copy all of them without much hassle. Let's have the most complicated for the last. Simplify this polynomial. I'll give you 10 seconds to think about it. Through observation, we can see that 9x squared is unique, so we just have to copy that. Meanwhile, we have similar terms 6x squared y and negative 3x squared y. If we add them, we should have 3x squared y. Meanwhile, 3xy squared and negative 6xy squared are also similar. By adding them, since negative 6 is greater, it will result to negative 3xy squared. And lastly, 9y squared is also unique, so that stays as is. So right now, I am hoping your brains were refreshed, so let's move on to the actual discussion of our topic. I've been reiterating special products for a while now, but what are special products? Special products are simply products of given factors that have predictable outcomes. Simply put, they are special because they are easy to solve. With this, you should be able to know special products once you see them. Let's get right to the first special products, which involve squares. We have the square of a binomial in the form quantity x plus y squared. Recognize this? This was number 5 in our recall activity. Basically, what we have to do is multiply the binomial by itself. If we are given x plus y squared, we would have x plus y times x plus y. Simple, right? Here comes the trickier part. By now, you should already know the distributive law of multiplication. So to simplify things further, the FOIL method, or FOIL method, is going to be introduced. But what exactly is the FOIL method? FOIL is an acronym that stands for first, outer, inside, and last. This basically means we have to multiply the first terms, then the outer, then the inside, and then the last. Please be guided by the lines. Let us try to use the said FOIL method. The first thing we have to do is to multiply the first terms. What are the first terms? X and x. Multiplying these two, we would have x squared. Get it? The next one is the outer terms. The outer terms are the leftmost and the rightmost of the expression, or in layman's terms, the terms outside, of course. Our terms outside are x and y, so the product must be xy. The next is the inside terms, the ones next to each other. We have y and x. The product must also be xy. Remember that when arranging terms or factors, one thing to consider is their chronological order according to the alphabet. Next are the last terms, the last in each grouping, which are y and y. Therefore, the product should be y squared. However, we are not done yet. We can see that there are similar terms xy and xy, and if we add them, we should have 2xy. Hence, the final product to this special product would be x squared plus 2xy plus y squared. We had x plus y squared for this one. But what if we had the opposite sign, x minus y? What would happen? Right now, we have to evaluate the square of a binomial still, but now a difference instead of a sum. Let's get right into the solving process. Note that the only thing we changed was the sign in the middle from plus to minus. Again, the FOIL method. The firsts are x and x. The product must then be equal to x squared. The outers, x and negative y, the product must be negative xy. The inners, negative y and x, the product must be negative xy, while the lasts are y and y. The product must be y squared. Yet again, we have similar terms, negative xy and negative xy. If we add them, we will have negative 2xy since they are both negatives. Hence, the final product should be x squared minus 2xy plus y squared. Let's compare this outcome with the square of the sum. Look at the two outcomes. We can notice that the only difference between the two is the signs in the middle, copying the original operation. This would mean that if we have a sum, we would expect a plus sign, while if we have a difference, we would expect a minus sign. To ease our solving process, we have a technique for this. We have 5 steps, but if you are more advanced, you may merge steps 3 and 4. However, for this video, let's take things slowly. The first is to square the two terms and add them. The second is to copy the sign in the middle and multiply the two terms. Then multiply that product from step 3 by 2, and if needed, we should organize according to different conventions. Let's try to put this into practice. Our example here is quantity 5s plus t squared, whereas our terms will be 5s and t. The first step is to square the two terms. Thus, we have 5s squared and t squared. For the first term, this would be 5 squared times s squared, and the second term will stay as is because we cannot simplify that even further. 5 squared will be 25 times s squared, so that will be 25s squared, and just copy the t squared. The next step is to simply copy the sign in the middle. Since our sign here is plus, we will just copy that. The next is to multiply 5s in t, so that would just simply be 5st. Step 4 is to multiply the product from step 3 by 2, or simply twice the product from step 3. The 5st we have obtained earlier will be multiplied by 2, so that makes it 10st. This will then be the product. But of course, the last step is to organize. The 10st and t squared will just change positions because, as I've said earlier, alphabetical order also matters. Therefore, the final product is 25s squared plus 10st plus t squared. I hope you've understood that because we will be proceeding to the second type of special product. This type has multiple names. The sum or difference of two squares, the product of conjugates, or the product of a sum and a difference. This is shown in the form quantity x plus y and quantity x minus y. Notice that the signs in the middle of the binomials are different, but the terms are the same. This is the main condition it must fulfill for it to be a special product. The terms must be the same. If we have x and y for sum, we should have x and y for difference. If we have 5 and t for sum, we should also have 5 and t for difference for this technique to work. Of course, the FOIL method is applicable for all multiplication of binomials. Like earlier, the first terms are x and x, which makes the product x squared. The outers are x and negative y, which makes the product negative xy. The insides are y and x, which makes the product xy, and the last terms are y and negative y, which makes the product negative y squared. On the other hand, look at the outer and the inside terms, negative xy and xy. If we add them, since they are similar and have opposite signs, they will be equal to 0. Therefore, the final product is x squared minus y squared plus 0, but since 0 is irrelevant here, we can just erase that. Now look at the final product, x squared minus y squared. That long process turned out to be something so simple. This is one of the simplest special products because it is very easy to compute for and is highly predictable. We only have to square the two terms and put a minus in the middle. That is actually our technique. The first step is to square the first term and the second is to subtract the square of the second term. Let's have an example. We are given 2r plus 8 and 2r minus 8. What are the terms? The terms are 2r and 8. Step 1. Square the first term. The square of 2r is 4r squared. I'm hoping you already understood that. The next step is to subtract the square of the second term. That is minus 8 squared. And 8 squared would be equal to 64. And thus, the final product is 4r squared minus 64. As simple as that. That would be all for these special products involving squares. I will be showing you the types and the steps in solving the different types of special products involving squares, which will be shown for 10 seconds, so look out for that. For the special products involving cubes, feel free to go over the description box since a link is provided or click the linked video about this. If you like this video, don't forget to like and subscribe. Meanwhile, type in the comments your suggestions and questions. See you next time and happy learning!